So good morning everyone. So as we are discussed about the pressure regulating valve, the first valve we are discussed, that is your pressure relief valve. So now we are discussing about the pressure regulating valve, that is non-relief pressure regulator. So you can see the diagram here. So this is the adjusting screw, this is the pressure setting spring, and this one is the diaphragm, and this one is your poppet. So when the outlet pressure will be reduces, then what will happen? When the outlet pressure will be reduces, this diaphragm and the poppet will be moved down, and the extra pressure inlet air will be added into the system to manage the pressure, or to manage the outlet pressure or to adjust the outlet pressure. Suppose in the inline pressure, suppose the outlet pressure will be more, what will happen? If the outlet pressure will be more, then the diaphragm will be move upward, as well as the poppet will be move upward, and the air will be bent away from the air will be bent away, and the pressure will be reduces in the outlet. That is the function of the pressure non-relieving pressure regulating valve. Okay? And as a steady state condition, the diaphragm and the poppet, in a steady state condition, the valve will be balanced the force of the diaphragm and the outlet pressure with the preset force on the spring. So what is that? So if the suppose in the system we need, so in the system, the pneumatic control system, suppose we are doing some work and that work needed 10 bar pressure, okay, and that will be adjusted by the adjusting screw. Okay, so if the outlet pressure will be less than 10 bar, then what will happen? The diaphragm and poppet will be moved down, and the air will be added, and it will be managed the outlet pressure. If the outlet pressure will be more than 10 bar, what will happen? The excess pressure will be cannot be sent to the system, so it will be bent away from the system. Okay, bent away, and the diaphragm and the poppet will be moved upward, and the air pressure will be bent away. Okay, so that is the function of the what? That is the function of the pressure regulating valve, that is non-relief type, and this one is the relief valve type. Okay. Next we will discuss about your air lubricator. So why the compressed air which will be generated, that should be dry and free from oil, that we know that, and some compensate lubricate air is damaging, and for other it is also undesirable, but the power component, it may be certain causes to be necessary. The lubrication of the compressed air should be therefore always be limited to the plant section which require lubrication. For this purpose, the MECH lubricator are fitted to fit the compressed air with a specially selected oil. As we know that the oil and the water vapor, that will be removed by the coalescing filter. Okay. That means it will be remove the air pressure also. So in the, though all the valves are used here, and valves are used, so it must be lubricated. So which lubrication system is it? The MECH lubricator is used, and we are using special selected oil which will be utilized in the compressor or mixed in the compressor. The oil which are introduced into the air from the compressor are not suitable for the lubrication of the control system component. As general principle, cylinder with heat resistant steel must be supplied with the lubricating compressor, and since the special grease which form a original lubrication would be washed out, if the systems which have been operated with lubrication are converted into unlubricated compressor, and the original lubrication of the valve and the cylinder must be removed, since they may have the flaws out in the some instant. So what is the principle of a main problem that will be occur if the resulting excessive lubrication is used? The malfunction of the component increase the environmental problem and seizing the component after prolonged downtime. Okay. What is the operation of the lubricator, MECH lubricator? The compressed air that you can see here, inlet, this one is your outlet, this one is your oil will be droplet here, this one is your siphon tube, oil reservoir, siphon tube. Here the oil will be in the mist form. Okay, this is the glass bowl, and air will be flow. So what will happen? The compressed air passing through the lubricator cause the pressure drop between the oil reservoir and the upper part, between the oil reservoir and the upper part of the lubricator. Then due to pressure difference, what will happen? From the oil reservoir, the oil will be move upward through the duct, that is the siphon tube, where it is then dripped into the nozzle, which can be seen through the inspection glass. And here the oil is atomized, and this is known as a mist, and taken up by the air stream to a greater or less extent. As the inlet air of the compressed air passing through the lubricator, it causes the pressure drop between the oil reservoir and the upper part of the lubricator. So what will happen? From the oil reservoir, the oil will be passed through the siphon tube and it will be again sent to the nozzle, where the oil will be formed in the atomized form and the air will be taken up by the air stream and to a greater or less extent, then it will be outlet. Thus, the oil carried out with compressed air into the system help to lubricate the system component. Clear? So this is the function of the what? Lubricator. So what you can see here, filter, filter, regulator and lubricator. This FRL unit will be used for filtration of the compressor, regulating of the compressor, lubricating the compressor. Okay. So this FRL unit, that will be trio, is used in the small pneumatic system. Then we will discuss about actuator. We are discussing single acting actuator and double acting. In the single acting, there are only one entrance that allow the compressed air to flow through, and therefore it can only produce the thrust in one direction. And piston rod is propelled by the opposite direction by internal spring. So when it will only one inlet or only one entrance, when the air will be enter into this side, then piston will be move forward or produce the thrust in one direction, right hand direction, and then again it will be moved back to the original position. How it will be moved back? By the internal spring force and by the external force provided by the mechanical movement of the wet body. So this is where the single acting cylinder is used. Single acting cylinder is in stamping, printing and moving material, etc. So you can see this is the pneumatic symbol of the pneumatic single. This is their inlet, one direction inlet port or one entrance. The spring is used where it will be returned to the original position. Then is a double acting. In the double acting cylinder, the air pressure is applied alternatively to the relative surface of the piston and produced by propelling force and retracting the force. As effective area of the piston is very small, the thrust produced during the retraction is relatively weak, and impeccable tubes of the double acting cylinder are usually made of steel, and the working surface are also polished and coated with chromium and reduction of the friction. So as the pneumatic cylinder, this is double acting cylinder. So there are two inlet to the cylinder. There are two entrances where the air will be inlet to the cylinder. Okay. So if the air will be inlet in the left direction, then it will move forward. So to come back or to retract, air should be passed through the right hand side, so that it will be in the right hand side. When it will be retract, the force or the thrust produced is very weak, as the piston is very small. So this is the double acting cylinder. Then we will discuss about what? Pneumatic valves. So first we will discuss intake filter, then compressor, between the compressor intercooler, then upper cooler, then we are discussing about the filter, intake filter. Then in the intake filter we are discussing is your standard filter, pulsing filter and vapor absorbing filter. Then we are discussing pressure regulator, pressure relief and non-pressure relief. Then we are discussing your lubricator. Now we are discussing, after this whatever the air will be passed through the valve to actuate the actuator or to run the actuator. So what is the valve? Valve is a device which is used to control the output of the circuit. And the main purpose of the valve in the pneumatic or hydraulic circuit is to control the final output. And the valve are divided into number of groups accordingly to what they control. So according to the function, example is your direction control valve, DCV, FCV and PCV. According to the design, this control valve is full type, poppet type. According to the actuation, manual, mechanical, pneumatic, electric or solenoid type. According to the mounting angle, manifold, inline, soft plate. and according to the application, that is speed control, signal processing and proportional valve are used. So these are the classification of the valve. Next we will discuss about directional control valve.